Here's a machine to flip a coin 10,000 times. Let's get flipping. Okay, so it's stuck on the edge, and now it should fail to find the coin, and then it will keep flipping until it finds the circle. And there we go. Back in business. I think it's actually pretty lucky that we saw that so early, because I'm not going to watch all 10,000 flips for 5 hours. It takes about 2 seconds to do an average flip. And now I'll show you all the parts that makes this work. The first thing is just this tall cage, which I was hoping to be able to do all the flips without a containment device like this, as it's kind of cheating, but there's just too many random bounces that even if all the flips go straight up and down, the bounce is what kind of shoots it off to the side. So I eventually just printed this ring and taped it on to keep the coin contained. So just as another look at the mechanism here. It moves very similar to like an iris shutter, but as you'll see, each of the arms only moves in a straight line. They don't actually rotate. And this ensures that no matter where the coin lands, we can always get it. And since in a normal shutter mechanism all the leaves overlap, that wouldn't be so good for pushing the coin around. Here nothing overlaps, and so we can use the full height of one of those arms that's about the same height as the coin we want to flip to go. And so one thing that I tuned in when I was flipping the coin is that you don't actually want the mechanism to close all the way, because if we get it too centered, then the coin gets hit almost dead center every time and it doesn't flip as well. And so I can't remember what it was, but essentially it would be something like, closing that far, and from there it's a little bit off center and gets a better flip. So here's the full thing. It has these 2 layers, and they're connected with these adjustable sides. And the top ring here is retained by a little piece that I actually glued on that has a step. So let me take off the sides and we can get a better look at each of those pieces. And one more thing just to see is that I have these paper shims to keep the side plate off the wall of the inner ring there, so that it had a bit of clearance. Alright, so here's the sliding mechanism. And if we take this top ring off, then we can see each of the leaves and how they work. Here's one of the leaves that has a tenon that slides in this groove, and then the metal peg which rides in one of these slots. So this top ring comes out. When it rotates, it pulls on the pin, and then the whole thing slides. You can kind of see that I have a bunch of Vaseline on all these sliding components, and you know, for its purpose, it does it pretty well. So I saw one or two mechanisms that looked like this, and the ones that I saw actually had an arc slot in them, which I'm not exactly sure what geometry they were using, but I couldn't get that to work very well. And so I just ended up with this straight slot, and I think it just doesn't deliver the force, you know, in the exact right direction at all points, but it seemed to work okay especially once everything was lubricated. And then the second component is the flipper, which I have attached on this base plate, which has which is adjustable for the center position. But it ended up being, like I mentioned earlier, just fine to only use the amount closed to vary the flipping. So here there's the wooden dowel, which has a pin through it, and that pin fits in a groove here, and then there's a cam that pin rides on, and then a spring with some adjustable points to get different flip amounts, but I ended up needing the most, and I could have switched the spring out too. Alright, so if we take this spring out and get a better look at the poker, and I rounded this off so that it would not make such flat contact, but it ended up flattening itself out pretty. And then this slides down, so you can see that cam shape, so that as it rotates, it pushes the pin down further as it gets around, and then once it rotates just past here, the pin gets pulled back by the spring, and it goes and hits the coin. And here's some time lapses I've generated by compositing the extracted coins on top of a base frame. And we can play around with whether we leave the old coins in place or change their alpha value. And then finally, with the result of our heads or tails determination, we can plot how those heads and tails land over time. So here blue is heads and yellow is tails, and the distribution looks pretty good. Here's a look at the output of the image processing pipeline that I wrote to detect whether the coin was heads or tails. The first column shows the coin extracted from the image, and this detection was done in real time for every frame in order to know when it was okay to start the next flip. Then the determination of whether it was heads or tails was done offline afterwards, so that I could try a bunch of different techniques, because as it turned out, this was a bit more difficult than I thought. Initially, I wanted to not use something like a marker on one side, but the webcam had a hard time capturing a good enough image to make that possible. So I added a black dot to the tail side, and I'll go through the steps that I used in the end. This is the original image, like I said, and then converted to grayscale. It then gets a blur, and we try and detect a circle of about the size that the small black dot is. And this is the same procedure, but with an even more blurred version. And finally, we threshold this blurred version to give us a black and white image and try and detect a circle again. The results of detecting those circles are just listed here with their radius, their distance from the center of the coin, because we know that should be about the same, and their mean grayscale level. So you can see that these are all dark circles of about the same radius, maybe 11 plus or minus 1, and they're all 32 plus or minus 2 from the center. And this is a very good case, and we can confirm that that's tails. In the end, my deciding factor was looking at the mean value of any of these circles. If it was dark enough, I called it a tails. So you can see this T3 group is where we have 3 positive results from these 3 different tests. And I have them sorted by their mean grayscale value, so we go from darker to lighter on this tails group. So if we scroll down, because there are all 10,000 images here, these get progressively lighter, and we must have just switched to the T2 group, which for whatever reason that did not come back as a positive, but for instance these two did, and it still marked it as tails, which is good. Here we can actually see some of the mistakes that it made. In this H2 group, we have 2 positives on these 2 tests here, but their mean grayscale value is very high, so it called it a head. I added a checkbox to each of these rows so that I could go through and manually mark which should have been tails. I spent probably way too long trying to get a 100% perfect detector, and I had to just call it quits at some point to be done with it. In the end, this method ended up with a 1.1% error result, which I think is pretty good over 10,040 images. And here are the results. Who would have thought that flipping a coin was 50-50 odds? Hope you found that interesting. Bye.